Alright folks, here we are again. We're going to continue with stoichiometry, and I can only hope that you're as excited to do this as I am today. Stoichiometry's kind of sort of fun, I think. So let's dive right into it now. In example 4, I want to find the mass of oxygen that's required to react with 100 grams of iron to produce the compound iron 3 oxide. So remember, the first thing we have to do is write the balanced equation. So that shouldn't be too hard. We have O2 as an oxygen, one of our diatomic elements, and we're reacting it with iron, Fe, and we produce iron 3 oxide. So the formula for that, let's work on that off to the side. Iron 3 means it's Fe3 plus, and oxygen, remember, is in group 16, so it's 2 negative. So we're going to make Fe2O3. So now we should be able to balance that pretty easily. Let's put a 2 in front of Fe2O3, put a 4 in front of Fe, and a 3 in front of O2. And I think that balances our equation. Now once we have the equation balanced, we know the mole ratio. 3 moles of oxygen reacts with 4 moles of iron to form 2 moles of iron 3 oxide. Well, I'm giving grams of iron here, and I want to find out about grams of oxygen. So that's certainly not in moles, so let's go ahead and convert grams of what we're given to moles. So 100.0 grams of iron, multiply by a line, of course, put grams of iron on the bottom, moles of iron on top, and 1 mole of iron weighs, let's take a look on our periodic table. Here's iron, 55.85 grams per mole. So grams of iron are gone, and this will give us moles of iron. So let's see what we end up with here. We have 100.0 divided by 55.85. Looks like we have 4 sig figs, 1.791 moles of iron are going to be used in this reaction. So how much oxygen are we going to need? Well, now that we have our moles of iron, we can find our moles of oxygen by using the mole ratio and the balanced equation. So 1.791 moles of iron, multiply by a line, kiddos. We want to hop out of moles of iron and get into moles of oxygen. So that mole ratio is 4 moles of iron need 3 moles of oxygen. So 4 moles of iron need 3 moles of oxygen. So moles of iron are gone, and let's see how many moles of oxygen are required. So 1.791 times 3 divided by 4 gives us 1.343 moles of oxygen are needed. Well, I didn't want to know moles of oxygen. I want to know mass of oxygen, don't I? So our last step is to convert 1.343 moles of oxygen into grams. So I'll multiply by a line, and we'll put moles of oxygen on the bottom, grams of oxygen on the top. Remember, 1 mole of oxygen we just had in the previous problem is 32.00 grams. So moles of oxygen are gone, and we will have the amount of oxygen required in grams for that reaction. So 1.343 times 32.00 to 4 significant figures, I get as 42.97 grams of O2. So to react 100 grams of iron, we need 42.97 grams of oxygen. Now, let's do it in one expression, because that's normally how we show this when we do our work. So instead of having 3 different steps here, let's show it in one expression, and then we'll do one calculation. Okay? So once again, we begin with 100.0 grams. That's the mass of substance given. In this case, it's iron. I'm going to multiply by a line. We'll get rid of grams of iron. We want to get into moles of iron, right? So we can use our mole ratio. 1 mole of iron is 55.85 grams. Now grams of iron are gone. Multiply by another line. We want to get out of moles of iron into moles of what we're into, oxygen. And the mole ratio is, once again, 4 irons need 3 oxygens. 4 irons need 3 oxygens. So moles of iron are gone. And our last step is to hop out of moles of oxygen and get into grams of oxygen. And 1 mole of oxygen is 32.00 grams. So moles of oxygen are gone, and we are going to have as an answer grams of O2. So let's multiply that out. And you multiply it out with me to make sure we get the same answer. 100 divided by 55.85 times 3 divided by 4 times 32.00. And I get 42.97 grams of oxygen again. Okay? That's pretty simple. A lot of teachers will shorten this stoichiometry stuff up into a pretty simple sentence. After you balance the equation, you go from, here we go, I'll use a different colored pen here. We go from grams to moles, moles to moles, and then moles to grams. So grams to moles, moles to moles, moles to grams. And you'll see, if we don't add any rouge and lipstick to these problems, that means we decorate them up and make them look a little more interesting. That's really the skeleton of what we do every time. So let's try example number 5. Why don't you try example number 5 by yourself? Now this is going to require you to write and balance an equation, kiddos, and then do all the steps of stoichiometry without my help. So try it. Don't be too scared. Try it. You might surprise yourself. So pause the video, and then when you're done, come back and we'll see how you did. Okay? All right. Welcome back. How do you feel about it? Good? All right. Well, let's see. We have how many grams of oxygen are needed to burn 30.5 grams of propane. And I give you the formula for propane. I didn't need to tell you the products. You knew that they were CO2 and water because this is a combustion reaction and we have a hydrocarbon burning, and so we're going to make CO2 and water. So let's start by writing the equation. C3H8 plus O2 reacts to form CO2 and water. Put a 3 in front of CO2 to give me 3 carbons on both sides, a 4 in front of water to give me 8 hydrogens on both sides, and a 5 in front of oxygen to give me 10 oxygens on both sides. So that equation's balanced. Now, did you guys start with 30.5 grams of C3H8? Yeah, and you recognized, I hope, that stoichiometry is the mathematics of a balanced equation, and that balanced equation gives us a mole ratio. So we needed to hop out of grams of C3H8 and get into moles of C3H8. So we have to figure out what a mole of propane weighs. So 1 mole of propane. Let's go to our periodic table, C3H8. So here's C. We have 3 of them. They're 12.01 grams apiece. H8. All right. That's 1.01 grams apiece. So we have 36.03 plus 8.08. So let's see what we get here. 44.11 grams per mole, if I did my math right. 44.11 grams per mole. Now, that gets us out of grams of C3H8 and into moles. Now we can use the mole ratio from our balanced equation. So we're going to get out of moles of C3H8, and we're going to get into moles of what I want to find out about. So we have to read the question again. We want to find out about oxygen, don't we? So moles of O2. So the mole ratio is, for every mole of C3H8, I need 5 moles of oxygen. So for every mole of C3H8, I need 5 moles of oxygen. So moles of C3H8 go away, and I'm in moles of oxygen. And our last step is to go from moles of oxygen to grams of oxygen. And 1 mole of oxygen is 32.00 grams. You've probably memorized that because we use it so much, haven't you? So moles of O2 are gone, and we're left with our answer, which is grams of O2. So let's do the math together, see what we get. 30.5 divided by 44.11 times 5 times 32.00. Did you get to 3 significant figures? 111 grams of oxygen would be necessary to burn 30.5 grams of propane. If you did, good job. All right, one more part to this. This is where I was talking about where you could add a little bit of rouge and lipstick and make these problems a little bit more exciting. Now, what if I wanted to know how many grams of air would be needed? Because when we burn propane, we don't burn it in a room of pure oxygen. We burn it in air. And air is only 20.7% by mass oxygen. The other 79% is nitrogen, kiddos. So how much air would I need to burn the 30.5 grams of propane? Well, here's a cute little trick I'll show you. If we need 111 grams of oxygen, right? And I want to get out of grams of oxygen and into grams of air. We can use this percentage as a conversion factor. Isn't it true to say for every 20.7 grams of oxygen, there would be 100 grams of air? Yeah, 20.7 grams of oxygen, see it's 20.7% by mass, would mean that out of every 20.7 grams of oxygen, you would have 100 grams of air. So that allows us to get out of grams of oxygen, and now we're in grams of air. Pretty cute trick, isn't it? So let's go ahead and multiply 111 times 100 divided by 20.7, and we would need 536 grams of air to burn that 30.5 grams of propane. Okay? All right, when we see each other next time, we're going to talk about something called limiting reactants, and we'll do a couple more practice problems. But this is stoichiometry. If you followed what I did in this video and the last video, you should be pretty good doing most stoichiometry problems that you run into. So, you've done a great job. Keep it up. We'll see you soon. Bye-bye.